Hello, everyone. How was your weekend? Good. You're early. So, first, let me start with the homework question. So, instead of making the due date for homework on Monday midnight, I decided to do it on Tuesday midnight. So, if you have any question on homework or any of the quiz questions, you can ask me on Tuesdays, and then you can complete the homework or quizzes before midnight Tuesday. Okay, so tonight midnight you have section 3.5, 3.6 homework, and there are two quizzes. One is based on 3.2 and 3.5, and another quiz is based on 3.6. You have 4 things to do tonight. Wait, is it in visa homework? No, from last week. 3.5, 3.6. So today we are going to do 4.1, 2, and 3. Which homework will be, the due date will be next week, Tuesday midnight. And quizzes. So next week we'll have 3 homework 1, 2, 3, and then 1 quiz or 2 quiz. I don't know. Okay. And your exam will be on Friday. We are going to finish 4.123. On our next class, we are going to do a review. If you have any question, if you don't have any question, I'll start 4.5, which will not be in the exam. Okay. So make sure you look at the review sheets well. And if you see any question is unclear or anything, we'll go over that on Thursday. And then if nobody has any question or anything, I'll just tell you which question will come from which part, and then I'll just start 4.5. Okay, any question, comments, concern, complain? Nothing? So, chapter 4. Chapter 4 talks about system of linear equations. System of linear equations means we have more than one line to look at the same time. And the solution is where the two lines intersect one another. So when you work with two lines, there are 3 scenarios we face. Either the two lines we are working with, they are 2 random lines. So when you draw them, they intersect one another somewhere in their life. Probably one is going upward, another might go downward, something like that. So they intersect one another. When they intersect one another, we get one solution. Solution means where they are touching one another. And when you have one solution, we say they have unique solution. So these are scenario 1. Now we have second scenario. The 2 lines you are working with, they're parallel, like these 2 edges. The edges are parallel to one another, so they will never intersect one another. Since they will never intersect one another, so we're not gonna get a solution. So the solution for 2 parallel lines is no solution. They don't have any solution. And then we have the third scenario. The 2 lines here working, they are the exact same line, but they just look different. So one line and second line, they are the same lines. Okay. One could be multiples of the other line. Like if one of the line is 2x, maybe the other line is 4x. So the same line just stretch a little bit more. So when we have the same line look different, they are touching one another everywhere, infinitely many times. So we get infinite solution in that case. Okay? So 3 scenario, 3 types of solution. Now, when we do have a solution, we call them consistent system of equations. For example, when we have either one solution or infinite solution. Infinite. infinite solution. So the one solution or infinite solution, when you have them, the two lines you're working with, you call them consistent system of equations. And if you work with two lines, they're parallel, we call them inconsistent system. It means the two lines you're working with, they're never going to intersect one another. So these are the background information. Three types of scenario, three types of solution. If you have solution, it's consistent. If you don't have a solution, it's inconsistent. And now we are going to do 4 things. One is we are going to verify, we're going to learn how to verify whether some answer, some solution is a real solution or not. So let's say they give you 2 lines and a solution, and they're telling you verify that the solution we have is a real solution. So in order to verify that, we are going to substitute the x and y value into both lines and see if the left side equals the right side for both cases. If not, the solution is wrong. So this is the first thing we are going to do. Second thing we are going to do is we are going to solve them. And we are going to solve them using 3 methods: graphing method, substitution method, and elimination method. So that's what we are going to do today. This is the background of this is the outline of our class today. Any question? And yes, this will be in your exam on Friday. So first thing, check whether some solution is a real solution or not. So we have 2 equations. 3x minus 2y equals negative 13. And we have x plus 3y is negative 3. We are going to see if the 2 lines, do they intersect at negative 5, negative 1. So maybe one is going that way, other is going that way. So you want to see if this point is negative 5, negative 1. Is it? So what you're going to do is we're going to substitute our x and y value into both equations. So first equation, 3x minus 2y equals negative 13. Second equation, x plus 3y is negative 3. This is x, this is y. So our x is negative 5, y is negative 1. So in the first equation, we get 3 times negative 5 minus 2 times negative 1. And we want to see if they give us negative 13. On the next one, we have negative 5 plus 3 times negative 1. And we want to see whether this is same as negative 3. So let's simplify. 3 times negative 5. What do we have? Negative 15. We have negative 2 times negative 1. Positive 2. And what is negative 15 plus 2? Negative 13. So we do have the same number on both sides of the equal sign. So the first equation satisfies our result. Now, if the second equation also satisfies the result, then yes, that's true. Otherwise, no, it's not true. So in the second equation, we have negative 5. And we have 3 times negative 1. Negative 3. What is negative 5 minus 3? Negative 8. Do we have the same number on both sides of the equal sign? Not same. So second equation doesn't satisfy our result. So what do you think? Is -5, -1 is a solution for this system of equations? No. -5, -1 is not a solution for this pair. And that's how we actually verify whether our solution is correct or not. Once you solve a system of equations, if you substitute that back into both equations and they satisfy both equations, only then your answer is correct. Otherwise, you did something wrong or the answer is not just correct. Any question? Mhm. Okay, then let's go to graphing method. So now you know how to verify the solution. So you're going to know how to find the solution. The ORS method is a graphing method because in order to find the solution, correct solution, you need to have a graphing paper and a ruler. If you don't have any one of them, you might not get the correct solution. So what we do in this method is that we graph the two lines and then we see where they intersect. And now we already know by now how to graph equations. We have three methods: either use plotting points, or use y-intercept and x-intercept, or use slope and y-intercept. So 3 ways, just graph them and then see where they intersect. Can I flip my page? So we have -6x minus y is -4, and 1/2 y is 2 minus -3x. So let's say we want to use slope and y-intercept. If you use x and y-intercept, we'll bump into a fraction. For example, here, if you use x-intercept, we get like this 6, both sides divide, and then we get a fraction. We don't want to deal with fraction. So instead of using x and y-intercept, it's better to use y-intercept and the slope to graph. So let's do them individually. Our first line is 6x minus y equals -4. Our goal is to convert them into y equals mx plus b format, because the slope and y-intercept will help us to graph. So first equation is this, and second equation is 1/2 y is 2 minus 3x. Okay, our goal is to get the y alone. What is our first step? To get the y alone. What do you do? Plus 6x to both sides. So we get -y is 6x minus 4. Is our y alone yet? No. We have a problem with the negative, right? So what can we do to get rid of the negative? Adding y doesn't help us because we want to have y alone. So you either multiply or divide by a negative. So let's say I'm multiplying by -1. When you multiply or divide by a -1, all the term, they change their sign. So y turn into positive, 6x turn into negative, and 4 turn into positive. So we got our first equation. Now we're just going to modify the second one. First thing we notice is that the order is not correct. So let's order them in correct way. So we have 1fy is, how can you rewrite this term? Negative 3x and the 2 becomes plus 2. Now we like it because we have y equals x and the number. But now we face second problem. Is our y alone yet? What can we do to make it alone? Our problem is lying with the denominator, right? What can you do to get rid of the denominator? So you multiply everything by 2. The 2 top, 2 bottom cancel out. And we have y equals negative 6x plus 4. Our second equation. No, because it's negative 3x times the 2. So we have 2 minus 3x, right? So we rearrange them. So negative 3x plus, and then 2 next. And you're multiplying by 2 only. If y had a negative, then we multiply by negative 2, it will turn into positive 6. And it's still negative 3x because we didn't change the sign. We didn't change the 2 sides. We only rewrote them, rearranged them. One side, the same side. And now you have 2 choices. Either graph them and see the solution, or just observe the 2 equations. What do you observe? Equation 1, equation 2. They are the same line, not same answer. They are the same line. Same line. So if the 2 lines here are working with the same line, what type of solution you have? One solution, no solution, or many solution? One solution means they're intersecting only once. But you have the same line twice. So how many times they're intersecting? It's not parallel. Parallel line will have different slope. I mean, not different slope. Reciprocal. Sorry, my bad. Parallel line has same slope, different y-intercept. But see, they have the same slope, same y-intercept, so they are the same line. So just draw one line and then you will see what is happening. Both of them have slope negative 6 and y-intercept 4. So we are going to start 1, 2, 3, 4, plotting the y-intercept. And then from there, we have to walk our slope. So we want our slope to be a fraction. We don't have a fraction, right? Can you make negative 6 as a fraction? How? Over 1. So the negative on the top means which direction we are moving? Down. 6. And 1 on the denominator. Good, you remember, guys. So from this y-intercept, we are going 6 down, 1 right. So we already have 1 down, 2 down, 3 down, 4 down, 5 down, 6 down. 6 down is here, and then 1 right is here. 6 down, 1 right, and 1, negative 2, and then 0, 5, 0, 4. For some reason, I can never draw a straight line with 2 points. I don't know why. So this is one line, and another line is the same line. So if you draw same line again, now the black line and red line, how many times they're intersecting one another? Infinitely many times. So solution means the answer is infinite solution. So same line, infinite solution. And you don't even have to draw your line if you have the same solution. I drew the line because on my MATLAB, you have to draw the line and to visualize the scenario, whatever solution you have. Any question? Was anything unclear or confusing? Not in class, but on my method, yes. In the exam, you don't have to use graphing method. You're going to use substitution and elimination. Graphing method is bad because, say, the line is not straight. And if your line is not straight, you're not going to get the real answer. Okay, so from graphing method, let's go to the substitution method. This method is called substitution because we are going to substitute one variable with an entire expression into the second equation, so that at least one equation we get using only one variable. We simplify the variable, we get the result. Yeah. Substitution method. The steps are, you solve for one variable from one of the equation, but if it's already solved, you don't have to do that. Once you have at least one variable alone in one side in one equation, we substitute that entire expression with that variable on the second equation. Simplify, get the result, and then substitute back into one of the equation to get the other variable. That's why it's called substitution, because you keep substituting again and again. So here, in this equation, in this example, we have 3x minus 2y equals 7. And the second one is already solved for x. They are saying that our x is y plus 3. So whatever y is, the x value is 3 plus more than the y. So we are going to substitute this x with the entire y plus 3 expression, because this is what x means. It's y plus 3. So first equation is 3x minus 2y equals 7. But instead of x, we are going to substitute the expression for x. The expression for x is y plus 3. So this x turn into y plus 3. That's why it's called substitution. We substituted variable x with y plus 3. And now our goal is to simplify this expression, get the y alone. What do you think is the next step? Good job. Distribute. So if you distribute the 3, what do we have? 3y plus 9. And we still have minus 2y, 7. And now see, we got an equation only in terms of y, and we are happy because there's only one variable. You can easily simplify. So do you see any like terms here? Which like terms do you have? 3y and negative 2y. So how much is 3y minus 2y? Y. So y plus 9 is 7. How? Subtract 9, subtract 9. So how much is the y value? Negative 2. So we solve for one variable. We know our result has negative 2 for y. But remember, when you solve system of equations, it comes with a pair, x and y. We have the y value, but we need the x value. How can you get the x value if you know your y value? Plug in. You can use any one of the equation, but I believe using this one is much easier because our x is already alone. So x equals y plus 3. And you're so smart, we already know that our y is negative 2. So we are going to substitute the y with the negative 2. And then what? 1. So we found our y value, we found our x value. Now we can write down our answer. Our solution for these two lines where they intersect is x equals 1, y equals negative 2. And that's it. That's all for substitution method. You substitute twice. Once, a variable with an expression. Second, a variable with a number you received from the first step. Any question? Yeah, this will be in the exam. Go ahead. Solve it. So if x isn't given, solve for x or solve for y. But usually when they are not, one variable is not solved, using elimination is better. So I have 2 examples with fractions. Try them. Are they same? No, they're different. Try them and let me take the attendance. You don't have to work alone. You can work with your neighbors. Brianna Almonte. Christina? Oh, yeah, okay. Catherine. Jolene. Govan. Madison Field. Here. Eric. Abraham. Not here. Stephanie. Leandra. Robert. Katie. Kimelcia. Maria here. Sandy's here. Michaela. Madison Orlando. Angie. Mazavin. Melvelis. Giselle here. Muhammad here. Tahsin here. Tahsin, how you're feeling today? Good? Gavin? Brianna, Texas? Carla? Yvette? Nick? Danielle? And Hassan? So how did you sing? Substitution. Try substitution. For now, try substitution. When you learn the elimination, then you can use elimination. Question? It's returns. They are not like a plus one. So what do you have? So you want to see that how much. So I think doesn't make sense to you to the upper. You have something close, right? You cannot put your y because the y cancel out. So plus 3y and minus 8. So minus 4 was here with a 4. But it's still graded for 30 to 200. So like 3y, 3y plus 2. How many of that? It's because everything so it's temperature again, the number of 3,004. One thing. The proper needs to be given with when you get out of the elevator on that side, and then you see the facts. 3 and 5. Good. If you want to done. The first year minus 3. So if you like to this room is 0 into this number. Okay, let's do it together. We don't have to So these are interesting because they don't have unique solution. They have weird solutions. So if we use substitution method, that means we are going to substitute x with the entire expression here in the second equation. So second equation is 4 times x minus 3y equals 20. So instead of x, we write 3/4 of y plus 5/2. And we've seen this before. Our next step is distribute. So we are going to distribute the 4. We get 4 times 3/4 of y plus 4 times 5/2. And we still have negative 3y and 20. Now, either you can multiply or you can simply cancel them. When you cancel them, you don't have to do multiplication. Similarly here, we have 2 on the bottom, 4 on the top. 2 goes to 4 twice. So we write 2 on top of 4. So we have 3y, 3 and y here. And we have 3 and 5, which is 10. Plus 10. And we still have our negative 3y and 20. Now, as most of you already seen, the plus 3y and minus 3y, they cancel out. So we actually have no variable left. The variable cancel out. We have 10 equals 20. Now, when all the variable cancel out, you have to ask yourself, the result we get, the two numbers we got, are the same or they're different? Is 10 and 20 the same number? No, right? So this is a false statement. 10 is not equals 20. They gave us something false. When you end up getting some false statement, it means it has no solution. So the two lines we are working with, they are actually parallel lines. They don't look like it, but if you solve for y in both equations, you'll see they are the same slope, but different y-intercept. Daniel. Elimination, it will work if you align x and y top of one another. For example, here. I think substitution is here better. Because you don't have to do any math once you're done with getting the fraction. You have to ignore variable and then you just observe the numbers. So if you can remember that something false means it doesn't exist, right? False never exists in our life. So false means no solution. The solution doesn't exist. And when you do the same thing on the other one, you'll notice the same thing. You end up getting a number and all the variables are gone. Distressing. So we actually have two choices. Either use the same method or you can solve for y in the next one. So I'll show you both. Let's use the same method for the first. So y is the entire expression. So 3x minus 5 equals 15. Instead of y, it becomes 3/5 x minus 3. We change this y with the entire expression. We do the same thing, we distribute. So 3x minus 5 times 3/5 x minus 5 times minus 3 equals 15. This is 3. 5 cancel out. We have 3x. And here we have another 3x. And what happens in the next term? -5 times -3? Positive 15. And we still have our 15. So see, 3x and 3x cancel. What is left on the left side of the equal sign? 15. And the right side of the equal sign? So is this true? 15 equals 15? True. So if you get some true statement, that means the two lines here are working at the same line. So that's why you have the same number on both sides. Infinite solution. We cannot because they cancel out. When you have no variable left, you have two choices, either no solution or infinite solution. In the left one, we get something false, no solution. Here, we get something true, so it's infinite solution. We only solve for x and y when they have one solution. And they cannot have one solution if the variable cancel out. So it's either when you have no variables or no choice. So this is if you use substitution method. Now, what Daniel did was this. Second method. Since the first equation has already y equals something, let's solve for y in the second equation. 3x minus 5y is 15. If you solve for y, you subtract 3x from both sides. So negative 5y is negative 3x plus 15. Divide by negative 5. So y is 3/5 x minus 3. So second equation is y equals 3/5 x minus 3. And look at the first equation. What do you notice? They are the same line. Same line. And same line means they're intersecting infinitely many times. So the solutions are infinite solution. I didn't use any method. I just solved for y and compared the two equations. Go ahead. Which one? Here? Yeah. So this is 5. 3x minus 5y. Here it's y equals. Oh. In here it was x equals. So you have to see which variable is alone. Oh. Send this. Which one is positive? Here. So we have negative 5y equals negative 3x plus 15, right? Now our goal is to get the y alone. So we need to divide by negative 5. So negative cancel out. 5 cancel out. We get positive y. In here we have negative and negative cancel out. We get 3/5x. So 3/5x. So just anytime you multiply two negatives, they cancel out. Divide two negatives, they cancel out. So two negatives turn into positive. So substitution method and solving for y and compare. So in the exam, you may not know which one to use. So I'll say if you see a variable is alone, go for substitution. And now comes our last method, either addition or elimination. It's called elimination method because we want to eliminate one of the two variables, either eliminate x or y in the first step, and then solve for the other variable. And it's also called addition because in order to eliminate one variable, we have to have the same number in front of the variable with different sign, and you have to add them to get rid of them. For example, if one equation has, let's say, 5x plus y, blah, 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 and we want to get to the x, we want the second equation to have negative 5x, and we don't care about the rest. So when you have positive 5x and negative 5x, then we can add the two equations and they cancel out. So you can eliminate x in that way. Okay, so that's why it is two names: elimination, addition. In order to eliminate, we need to add, so it's called addition. And you're eliminating, so it's called elimination. So the method we use here is first you decide which variable you want to eliminate. Once you decide, then you match their coefficients. Okay? The coefficients must be same number with opposite sign. So which one you want to eliminate here? X or the Y? Y? Okay. So our goal is to eliminate the Y's. But we have a problem. I mean, we have one problem, one not problem. Not problem is that their signs are different, so you have to reset. When you add them, you're supposed to get something 0. But the problem is our coefficients are not same. So if you add them, they don't get cancel out. X is easier, but let's stick with our Y, no problem. So we want to have plus something Y, and sorry, we already have plus something Y and minus something Y, and our goal is to, when you add them, they cancel out. Okay. So what coefficients we can have in front of them so that when you add them, they'll cancel out. And that coefficient is related to both 2 and 3. It means we have to multiply both equations by something so that both 2 and 3 turn into same number. 3. If you multiply the first coefficient by 3, so the first equation by 3, we get 3 times 3, 9. Can you multiply 2 by something that it also turn into 9? Your idea is okay, but which one you want to multiply? The first equation or the second equation? Right. So what can you multiply by so it becomes a bigger number, but it will match with y, the second y? Then we don't worry about the sign because the signs are already opposite. So your 3 is correct, but you're not going to multiply the first one. You're going to multiply the second one. If you multiply the entire second one by 3, this becomes 6y, right? So we have 6y, and then the x becomes, sorry, multiply by this. X becomes 9, and the 4 becomes 12. Now, want you to multiply the first equation by so that the y becomes 6y. Multiply by 2. So x times 2 gives us 2x. 3 times 2 gives us 6y. 17 times 2 will give us 34. So 2x minus 6y minus 34. So in order to eliminate one variable, you want the same number with opposite sign. We had the opposite sign, so we are happy about that, but we did not have the same number. So what we did, we used a trick. We multiplied this 3 by this 2, and this 2 by this 3. So you multiply one by another one, they will become the same number, right? So if they don't have anything in common, just multiply one by another one. The life will be easy. So we are going to add them. Plus 6y minus 6y will get eliminated. How many x's we get end up with? 11x, and we have negative 34 plus 12. Negative 34, but plus 12. Negative 22. To solve for x, we do what? Divide by 11. So how much is x? Negative 2. See, we eliminated y, we got x. But you also need to solve for y, because our solution has an x and y. Now you're going to substitute to get the other variable. So you take any one of them, the first one or second one. Let's take the second one because our y is positive here. It doesn't matter which one you take, okay? So we have 3x plus 2y equals 4. We can also use the first one, it doesn't matter. And you already found that our x here is actually number negative 2. So it's 3 times negative 2 plus the 2y gives us result 4. So what do we have? Negative 6, 3 times 2. Negative 6 plus 2y equals 4. Our goal is to get that y alone. Add 6. So 2y is how much? 10. And then divide by 2. So our y is 5. So,
Because we have a variable left, you can go ahead and find the previous two examples, this is a number equal a number done.
We're done. So solution comes as a pair negative 5. Again, you don't have to get rid of y. You can actually get rid of x first. But it's good to know the methods to eliminate any one of the variables. In the next one, let's say I want to get rid of x. We must align the variables. Align means we want the same variable top of one another. So we have x on the first one, 3x on the bottom one. Our x is already aligned. How about the y? The bottom one has 2y. Do we have y on the first equation on the second term? No. So we must bring this 5y from here to there and bring 15 from here to there. So switch their position. So the 5y is negative on the other side. If you bring to the left side, what will happen to the sign? It will change, it will become plus 5y. So we are switching the position. 15 is positive on the left, but we want to bring it on the right. Negative 15. And the bottom one is already a number, so you don't have to worry about the bottom one. And now it's aligned. XX, YY, number. And now let me show you how to get rid of the X. In the last one, we got rid of Y. Here, let's get rid of X. So we have 3x minus 2y equals 23. On the second one, we have B. If I want to eliminate my x's, what number I want in front of x? But 3x plus 3x will give you 6x. I want negative 3. So negative 3x I want here. But how can you turn x into negative 3x? Multiply by negative 3. So multiply the entire equation by negative 3. So negative 3 and x gives us negative 3x. We can eliminate. But what happens to the y? The 5y turns into negative 15y. So we get negative 15y. And negative 3 times negative 15, positive 45. So we add them. And then 3x cancel out. We got rid of one variable. We eliminated x. And we observed the y. Negative 15y minus 2y. Negative 17y. And we have 45 plus 23. How much? 68. To get the y alone, by negative 17. So negative 17 cancel out. And now we actually have to find it manually. Again, that is calculator. Negative 4. So you have to see what is 17 times 2, 17 times 3, 17 times 4. So anytime they give you a division, and if it's simplificable, it will be smaller. Okay? Something that big. And this is actually a final exam question. They put this one in the final, and you have to use it. You have to use your brain to calculate this, not calculator. So we're happy that we found a y variable. But we're not done, right? Our solution must be in x and y. So which equation you want to use to solve for x? The first one or the second one? You can use second one, but let me use the first one because my x is already alone there. Definitely you can use the second one, okay? No problem using the second one, but I want to save my time. So we have x plus 15 is negative 5y. We can subtract 15. So our x becomes negative 5y minus 15. And we know y is negative 4. So negative 5 times the negative 4 minus 15. Negative 5 times negative 4. Positive 20 or negative 20? Positive 20. And 20 minus 15? 5. So our solution, x5 y negative 4. See, when you can solve for one variable, you definitely can solve for other variable. But the two examples we did before, the variable that cancel out, we had nothing to solve for. So when you have nothing to solve for, you stop and you have two choices, either no solution or infinite solution. No, I want to see the solution because solution comes as a pair, not as two different variables. Comes as a pair. Question? So the first equation is x plus 15 equals negative 5y. And we have to solve for x anyway, right? So I just subtracted 15 from both sides before substitution. So you subtract 15 from both sides, plus 15 minus 15 cancel out. We get x equals negative 5y minus 15. Negative 5y minus 15.
So you would use that.
You can. So
The one that on top of that.
what is your y? What is negative 5 times negative 4?
No, I use that one. Positive five.
Use this one?
No, that.
This one?
Yeah. X plus 5 equals 15.
So x plus 5y equals negative 15.
So I substituted.
Substitute y, right?
Yeah.
So it is 4 times 5 times 4, negative 20. And then you have to add 20, right?
Right.
So if you add 20, you have positive negative 15 plus 20. It actually doesn't matter which one you use. You can use any one of the equations you want to it. You're supposed to get the same answer. Any question? Then I have few examples. So one of them is here. Let me put another one here. So what do you mean is 2x y7? 2x plus y. S plus y7. Oh, it's a 7. And the other one was 2y minus 4x. Ah, I didn't save it. Come on. Let me solve the work. But at least you have them in your paper, right? Okay. So I wanted you to do this question, the last one here. And there was one more. Let me just copy and paste. Which one we didn't do this one? It's a new page. Okay, try this too. Using any method, elimination or substitution. And remember, our exam is on Friday, and it will be based on chapter 3 and these 3 sections we just covered. Past day, if you have a question, then we are going to do a review. Otherwise, I'm not going to do any review. I'll just tell you what will be in the exam, and then you will start 4.5. But 4.5 will not be in the exam. Okay? So make sure you take a look at the review sheet If you have no idea where the review sheet is, it's on our Brightspace. Under exam review, you'll see I posted both PDF version and the Word version. So any one of the other is fine. We only 1 hour 15 minutes. Yes, you can definitely come early, like around 12:30, right? Or class starts on 12:50. If you come around 12:30, I'll be the exam early. But definitely don't be late. Brianna came late. Jolene, no. Abraham absent. Yvette absent. Okay.
Now we can be substitution first.
You can, if you suffer one variable, but for example, to us, you're not going to solve one with this. When elimination is not to get to one. So what we have done. The X section allows one letter selection. Negative is on one point. 1, 3, and 2. It's clear negative is different. And in the final exam, you have two of these. One will have unique solution, like the question we did, and one will have either no solution or it is. So two questions from these two sections to be the final exam, and there will be one question from 4.5. So I'm giving you all the content. Make sure you collect them. Looks like about this, you can actually never have it on the top or on the side. Maybe even the side or top. I don't know. Two. What two are say? Also want to have as a consideration. Yeah. So consider here. And two more notes, two more place ones. So I actually still close. How are you doing? All right. Let me think of another one. Did I miss? Let me see the review sheet. That's for our first class. Which one we didn't do from the review sheet? E. E looks like we didn't do E. Try E. Oh, let me make it bigger. It doesn't get bigger. Oh. For some reason, I can make it bigger. Maybe I can make it bigger here. Give me 1 second. Ah, I got too bigger. Can you see? Yeah. Did you do all the other ones? One video was done. Eight that's minus eight. How come three? Oh. So, people out, why people out? You said, wait, how the what?
Okay, I wasn't sure.
So by three, I want to make people out. Yeah, zero, code. Please write it down. Zero equals negative. Then zero, four. Anyone? Okay, so in one column, now get the one column. 1.1. Forget. The bread is a like we are having a happy flow by every 100 seconds.
Yeah. Yeah. No, okay. Coming, which of somebody is because one with the after okay. So they have six flow. They're done a straight line, but they have a six flow. Exactly. Oh, yeah, I think it gets flat. So I just want to see you are trying to get to the what? The one. Are you sure you're the right? See you tomorrow for the science. Fine. Oh, which are you doing? Oh, yeah, let's see right now. What is UI? So we actually don't need to do it as we do it for next. You can add them if it's wrong. So we got we get 2 plus 4. How many else? 2 plus 4.
Oh,
And I'll do another set. 9 plus 1. This is 16. 6s2 is what? And a 6s3? So one will go count. Now from one of the equations, so find the So 9y to 9 perfect. And then it's going to 1. What is the same sign between 9 and 1? No. What sign you have between 9 and 1? Here? No, 9 and 1. Close.
9 and y. So you have 9y equals negative 9. So what is the sign here between 9 and y? Do you see a sign between 9 and y? People? No. When you have 9y equals negative 9. If you want to subtract, you have to have a plus sign between them. Do you have a plus sign between them? So can you subtract? Also, you know, no. What symbol is between 9 and y? Nothing, right? That we see an invisible multiplication. So what is the opposite of multiplication? What is opposite of multiplication? Division. That is to divide. To divide. Right. Cancel. 1 and 1. Negative 9 minus 3. We have 9 like that, and you're doing another 9 like that. Negative 9 minus 9. So you add the two numbers and give it back. What you dividing? Sorry. 9 divided by 9 is 1. Negative 1. You know what I'm saying? Then this is back to numbers. No. So you have your y, and then you go back to 1 of the question. And then
So I can do it every Thursday?
Sure.